Okay, this is the second video on Bernoulli random variables, and we're going to focus on the mean, variance and standard deviation of a Bernoulli distribution. Then we're going to use that to solve a couple of problems, and just a quick rehash of things that you ought to know if you're watching this video. We looked at previously that a typical Bernoulli trial probability distribution might look like something in the table there, where we have P as a defined parameter, the probability of what's often called a success in a single trial, and that's what a Bernoulli trial is. In this particular case here, R represents the number of successes, and you'll see different symbols used, sometimes lowercase y, sometimes lowercase x, and many other things. So that's 0 successes, which means on one trial, no success. And one success out of one trial has a probability of lowercase p by definition. You should also be familiar with, if you're watching this video, the discrete probability distributions, what they all mean, and some quantities to do with discrete random variables. If we use x, we have the mean. So if you're watching this, you should have seen in previous units of study that the mean has the symbol e of x, which means expectation or expected value. So that's the idea of expectation, the expectation of something, or it's often called the expected value. Okay, expected value is a common term. Sometimes we see the symbol mu instead. So e of x and mu are the same thing here. Okay, and it's the symbol. The symbol here is sigma, which means the sum of all the values p sub I up to x sub I from the first through to the last. Sometimes an alternate notation with an alternate formula, which means the same thing, is given as such. And this one here lends itself very nicely to the Bernoulli distribution you can see there from the previous work. But if you look closely, they're just different symbols. Okay, so two examples of different symbology, but hopefully you can see that they mean the same thing. You can use whatever symbology you like, I suppose, but you need to be able to read or respond to a task using the appropriate symbology. The other quantity is variance, and the variance we've seen in two different types of formulas. Var x is the sigma of p sub I times x sub I minus mu all squared, or the variance of x is e of x squared minus e of x all squared. This is from previous units of study, so go back and watch those videos if you can't remember or you've not seen this. Now remember, the relationship between the standard deviation and the variance is given as such. Okay, so standard deviation is simply the value for the variance. You take the square root of that. Now, how does this apply specifically to a Bernoulli situation? If we look at the mean first for this type of distribution, and this is the simplest of all probability distributions. So if we look at the expectation of x, or expected value of x, which is mu, the mean, in other words, using one of the two formulas there, it works with both. We write it down, and then we sub in what we've got. Now what that means is that sum all of p times x for corresponding values. Now we've only got two, if you remember the table, we've only got two entities to sum together, these two. Now thinking back to what you know about this thing called expected value, it's basically the sum of the probability of a success. Now I'm just putting this in a thinking cloud here, that's not part of the actual response to the task, times the value of the success, and the probability of a fail times the value of the fail. Okay, so we've actually got values, or the number of successes in one trial. So that would be 1, that would have a value of 1 in a Bernoulli, because that a success in one trial is one success and no successes, okay, in the case of the fail. We also know that this probability of fail sometimes is the symbol Q, or it is 1 minus the probability of success. Now we call the probability of success usually just little p. Okay, so we've got to add them together. Now using the symbol p, so we're doing this in terms of parameter p. Parameter p, so we'll see little lowercase p's in our response. We have the first one, whether we start at success or fail doesn't matter. We've got the probability of success, which is little p, the value of it, or in other words the number of successes in 1, that would mean, which would be 1, so p times 1 plus, we could write q, but I'm going to do it in terms of parameter p, so we're going to use, instead of q, we're going to use the complement of p, 1 minus p, and its value is 0 successes. So that would be p, and that's it. So basically it's p. So the mean for a Bernoulli trial, one Bernoulli trial, is p. Okay, that's noteworthy. So note it. For the variance of x now, you could use either formulas. Okay, I'll show you both very quickly. I'm going to do this one in real time here, and we've got sigma p sub I by the square of x sub I minus mu. And that means we have to add all those corresponding things together. Okay, we've only got 2, remember, so the first one, let's go for the success now. The probability of success is defined in terms of lowercase p as lowercase p. Now we've got x sub I for the first one, it's a 1, and we have mu is p. So we then have the fail situation, the non-success. Alright, so that would be the probability of that in terms of parameter p is 1 minus p, and then we have its value is 0 minus, again, p, and I've got to put my squared in. Oops, apologies. Now this term here would be negative p all squared, so I'm going to put that out the front and trade places with the 1 minus p, and then negative p squared, negative p all squared, is p squared. So we've basically got 1 minus p all squared, and this here is just p squared, and 1 minus p here, and we can take a factor. If we look at both of them, both terms there have a factor of p times 1 minus p. If you pause and have a look at that, and so you would have 1 minus p plus p left over if you have a look at that. So if you take a factor of p outside of 1 minus p out of those two terms from the line above, and of course in this part here where you can see my cursor, we have minus p plus p, so that's 0, and so in that square set of brackets we just have 1. So that means for a Bernoulli trial, for a Bernoulli distribution, var x, or variance of x, is p outside of 1 take p. So that is also one to note. That's in terms of parameter p. If you use the other formula, that's what you get, and you get the same result there. Okay. In the previous video we saw this worked example here about a cream. Lab tests say it's effective 72% of all the cases. Now from that you determine that lowercase p is a constant, it's a Bernoulli trial, and it's 0.72, okay, because we want the person to be successful. And we saw this actually, the first part, the probability distribution, in the previous video. Now let's use all that to determine the expected value of x, or the mean. Okay, so let's go ahead and do that. Well, the mean is simply p. So for a Bernoulli distribution, so we're talking about Bernoulli. So really, E of x, or the mean, is 0.72. Easy. For the variance and standard deviation, then we use the results from above, and we have for Bernoulli, we have the variance is p times, did you notice that that's p times its complement? Oops, that's a p. There, that's better. Okay, I nearly wrote a Q there. So, well, that's 0.72. And we just go take 0.72. And that's 0.28, and that comes as 0.2016 to 4 decimal places. And straightforward, we have the standard deviation. So the standard deviation, using that notation, is the square root of that value. Okay, I think I went through that before, didn't I? Back up here, we had, and apologies if I didn't, I might have got carried away. Sometimes that happens. So the standard deviation is the square root of the variance. Hey, I don't know, I'll have to go back and see if I actually said that. But there it is, just as a reminder. And 0.4490 to 4 decimal places is the standard deviation. Finally, now in the video, we're going to solve a problem. So Ali and Jack are about to play a game of chess. Ali's more experienced, so the chance that Ali wins is greater than 50-50. It's actually 0.68. So that's what little p equals. And we assume that remains constant because this is a Bernoulli trial. We're modeling it by let y, and that's the variable, that's the symbol we're going to use. Let y be the discrete random variable that defines the fact that Ali wins. So a success is Ali winning. Okay, so it's defined and it's constant, and there it is. He wins or he loses. Okay, that's how we're modeling this. So construct a probability distribution table for y, and then we've got a few things to evaluate after that. Okay, so with Bernoulli we have our symbols. So if it's capital Y is the variable, we put lowercase y up here as you've seen before, and this is the probability when the variable equals those values of lowercase y, and we can have 0 wins or 1 win in one trial, and p is 0.68, so there we have 0.68 in that cell, and the complement of that 0.32 goes in that cell. So there's part A completed. Now we've got 3 things to calculate here, and let's do them. So that was part A. Part B, we need to find E of y, and E of y is merely just lowercase b, and that equals 0.68. Easy. We're going to use that 0.68 now for the rest of it. So the variance of y is p times its complement, and that's 0.68 times 0.32, and that's to 4 decimal places if we go that far, 2176.2176, and the standard deviation is a square root of that value. Okay, so standard deviation is the square root of the variance of x, and we have the square root of 0.2176, which is 0.4665, I get, rounded to 4 decimal places. And the very last part here, I'm just something a little bit unexpected, and it's just I guess it's a sneak preview of what's coming ahead with other sorts of probability distribution. So let's have a look at this. It's a bit of an extension, but it's a good application. So that means the probability of mu take to sigma is less than or equal to x, which is less than or equal to mu plus 2 sigma. Now, sigma is another symbol that relates to standard deviation. And 2 sigma, sigma is a Greek letter by the way, 2 sigma is 2 standard deviations. Okay, we talk in terms of that with probability distributions, especially with continuous probability distributions, which is where this stuff's used more, but it is used in discrete as we are now. The other thing to note is this symbol mu here is that same mu. Okay, it's still E of x. Okay, so we're basically looking for the probability, capital P, probability of this thing y being equal to values of lowercase y, such that they're between these values mu take 2 standard deviations and mu plus 2 standard deviations. So what we're going to do is calculate mu minus 2 sigma and then mu plus 2 sigma first of all. We know the mean is 0.68, the standard deviation is 0.4665. So sigma, which is the term used when it's used this way, and more about that in future videos, is 0.4665. And 2 sigma is 2 lots of that. And crunching that, I get 0.9330. Don't need a calculator for that. And so mu take 2 sigma, which is again there, is basically that mu there, take that 2 sigma there, and you get a negative, and I get negative 0.253. Mu plus 2 sigma, same process, but we add the 2 sigma on this time, and we've got 1.613, if I've done that right. Okay, so what does that mean? So we're finding the probability such that the value of the variable for y is between negative 0.253 inclusive and 1.613 inclusive. Now if we look at the inputs that go into this probability parameter, which is what the contents of the brackets are, it's these things. It can only have 2 of them in a Bernoulli distribution. So let's see, it'll either include one of those, or both of those, or perhaps neither of those. So we'll have answers which are made up of things like this, which we know the value of, and things like that, which we know the value of, or both or neither. So the 2 values there are 0.32 and 0.68. So let's remember that. So finishing off now. So 0.32 and 0.68, I just noted that there, and that would be fine for both of them. 0.32 and 0.68 is within that range there. It's within that. So that would mean that that would be probability of no wins plus probability of 1 win, which is 1. As I said, you don't always get both, you might only get one of those, for example.